Good morning, Pratiksha madam.
Good morning, ma'am.
Yeah, so thank you so much for joining us. Before going ahead, I just want to give you a little brief about this program. We have this field project for second year student, which is compulsory component of the University of Mumbai syllabus under the NEP. So under this program, all the SY students across all the stream of the college doing field project where they have to actually go to the field, collect data, analyze, and finally they have to write a report. So to support them, we have designed this program under the guidance of our principal, Professor Dr. Sibyl Thomas, to support our students to carry out this field project. So in this program, we have conducted many few sessions of information literacy program where we make student information literate, and few research methodology programs which includes introduction to research methodology, how to do literature review, and qualitative analysis we have finished, and data collection tools and sampling. So today we have this quantitative analysis, and I'm sure that our students will going to benefit with your session, and they will use this thing for their field project. So without taking much time, now I would request Professor Jenin Coelho to introduce today's resource person. Professor Jenin Coelho, over to you.
Thank you, Dr. Sujata. I'd like to welcome and introduce our speaker for today, Dr. Pratiksha M. Kadam, who holds a PhD in mathematics from the University of Mumbai and is an assistant professor in the Department of Statistics at KC College, HSNC University, Mumbai. She has over 15 years of teaching experience in mathematics, statistics, and computer science, with a focus on integrating digital tools such as Power BI, Tableau, Python, R, and Google Suite into her teaching practices. She is a Board of Studies member in statistics at HSNC University and has served as a visiting faculty for MSc programs at the Institute of Science and KC College. Dr. Kadam has authored research papers in reputed journals and contributed to books on R and Python programming. She has conducted invited talks and training sessions on data analytics, LaTeX, and Power BI for students, faculty, and professionals. Dr. Kadam has also served as the NSS Program Officer at KC College, actively involved in organizing and participating in various community outreach initiatives. Appointed as a member, Financial Management Committee for the 17th state level Avishkar Research Convention of 2025 and nominated by the Honorable Chancellor as a Raj Bhavan representative. Dr. Kadam, welcome to this session and thank you for sharing your expertise with us this morning.
Thank you so much, ma'am, for the elaborative introduction and for inviting me for this session. What we are going to do in this session is I'm going to give you the brief layout about how the quantitative techniques and how different quantitative techniques can be used in data analysis so as to it will be helpful for you to write your research project report in a better manner. And I'll be sharing the screen with you all. We will go through the document, and if you have any queries, you can ask me about that as well. So this is, I hope the screen is visible to you all.
Yes, ma'am. Screen
Yeah.
is visible.
Okay. So we are going to, basically, I'm going to cover the types of data. Then we will see some descriptive statistics techniques here, which are majorly used in the data analysis. Then the major graphical representations of the data. Then probability distributions. This probability distributions part or inferential statistics part might not be very familiar to the students who are not from statistical background or so, but you will be able to, if you can read and if you can understand what is the use of these distributions and all, then you will realize that it might be useful to interpret your data in the proper manner. And so as you can put your data in a suitable software and run the test also. Since the topic is restricted to quantitative analysis, here I have not given any software-based approach to this particular lecture. But I would like to ask the organizers if they want, I can give them the brief gist of the software based also towards the end. I may have a presentation where they can use Excel because many of them might be familiar with Excel. So a few slides about how can they perform all this quantitative analysis on Excel. Those I can share towards end if we can include those in our current session. So I would like our organizers to brief me on this if it is okay. Otherwise, we will restrict ourselves to the theoretical part, whatever way. Okay. Then we will move on to the inferential statistics. We will also see some advanced methods of data analysis and a small case study where I have taken a small data set for your understanding how the different, statistical techniques are applied to that data set, and then further you will be able to analyze your data set in the similar manner and you will be able to apply those skills on your data set. So this will be our today's flow. Okay, so to begin with, now the quantitative data analysis. What do we think about quantitative data analysis? As soon as you come to know that there is data which is quantified, which is numeric data, and you would like to draw some conclusions based on that data, right? So the quantitative analysis is a process of working with numerical data. For what? We would like to find out some insights from that data. We would like to make some predictions from that data. We may have some hypothesis in our mind, and we would like to understand or we would like to see whether those hypotheses are true or false, and the some methods that will be useful to prove these hypotheses either true or false. Those methods we will be learning in this particular session. All right. Then this particular document is, I had designed this for the students of statistics. What is the meaning of this? So, quantitative analysis means analyzing the numbers instead of words or observations. So, there are various types of data. Not necessarily always you will have a quantitative data. Sometimes you have qualitative data as well. And there are different methods of analyzing that data too. And nowadays, word cloud, then sentiment analysis. These all are the fields in which you can even analyze the qualitative data, and you can get better insights when your data is related to some psychological aspects or something. It is very much necessary that you find out the tone of that data, you find out the sentiments from that data. So in that case, we can use qualitative analysis as well. But our today's focus will be on quantitative analysis. And why does it matter? Because it is widely used in businesses, economics, health sciences, and many other streams also. So for that, understanding the different data types is essential. So what all types of data types are there? Broadly, we consider there are three different data types: nominal, ordinal, and ratio. So when we consider the nominal data type, it represents the categories without any order. So for example, I say this is the data about fruit preferences, or you may have a data about number of students in different divisions. So even if I write ABC or BCA or CAB, doesn't matter because there is no order to those divisions, right? So here it is given types of fruits, blood groups. Only the frequency or mode are meaningful in this case, and arithmetic operations cannot be performed on the nominal data. So, such data is on this data, you cannot perform too many operations, but this is one of the data types. Then there is an ordinal data where the order matters. So, for example, you have grades in your system. So I have considered the data about your class. Then in that data, I would like to see how many students have scored O grade, how many students have scored A grade, and so on. But here you all know that O, A, B, C in this case have order. They are ordered. They have the hierarchy in them. Whereas similar ABC were there in case of our divisions, but there was no order mattering. So whenever there is an order which matters, our data which is counted over there, that type of data is called as a ordinal data. And then there is ratio data. So what the ratio data has? It has the interval type properties. Okay, it has a true zero. So when you consider weight, height, income, all these things do come under your ratio data. And all the type of statistical operations, including geometric, harmonic means, everything can be calculated for ratio type of data. So these are three major data types which we come across whenever we are going to collect the data. Now, the data collection part I have not added here. That part we will discuss orally, that is okay. When you collect the data, first thing is you all should understand that data is whatever we see around us is the data. When we structure our data in certain manner, it is called as an information. When information is attached to some meaning, and when information gives some insights, it becomes knowledge. So that is a data curve. Okay. And now, when you are going to work in the industry or somewhere, when we are going to work on a particular problem, what you will require first is you will require to collect that data. So there are multiple ways of collection of data. So one of the ways or majorly used way is the questionnaire. Many times you might come across, or you might have been sent different questionnaires or Google forms, and you're asked to provide the data for those Google forms. So questionnaire is one of the form. Another form is personal interviews. Then there are mailed methods by which you can collect the data, or you can go to surveys and you can collect the data. So these are the different ways of collection of the data. Now, once the data is collected, what you have to do is you have to first clean your data, you have to arrange your data, and then you can apply the different techniques to that data. So we are going to see which all techniques you can apply on this data now. Okay. So to apply those techniques, the very first and basic techniques which we must be learning is the descriptive statistics. So the descriptive statistics summarizes and presents the data in the understandable format. They help in simplifying large data sets. So when you are going to collect the data, large data sets, basically always remember, when you have more number of responses, or your data is bigger, your analysis is, or rather the insights which that data gives, are more better. Lesser the data, lesser the accuracy of your analysis. Always remember this. So whenever you collect your data, you must collect in a good amount or good number. Then descriptive statistics summarizes and presents the data in understandable format. They help in simplifying large data sets into the meaningful summaries, making patterns easier to see. So they are broadly classified into two. One is measures of central tendency, another one is measures of dispersion. So, whenever we say central tendency, what is the meaning of this? These indicate the center or typical value of the data set. So, for example, I consider one of the value and I say this value represents this data. So, sometimes mean is that value, sometimes median is that value, and sometimes mode is that value. So what is the difference between mean and mode and median? See, arithmetic calculations of mean, mode, median, you will be able to find out in any of the books, as well as if you just put your data in the softwares, immediately you get these answers, because everybody need not learn the calculation part of it, but you should know the meaning of it at least. Okay. So when I say mean, mean is the arithmetic average. You can have, so there are different averages as well, geometric and harmonic as well. But majority of the times when you focus on this mean, this mean is usually sensitive to extreme values. And hence, this is useful when your data is symmetric and free from outliers. So let me explain you. Mean is the average of the values. So when your values are close by to each other in the data set, you get the better approximation of the mean. But if you have some values which are not within your range, which are outside the range, then in that case, what happens is you don't get the good mean. So, for example, there is worked example here. These are the values given to you, and mean is 6. But if I have values like 2, 4, 6, 8, 10, and the last value mine is 57, now at least we can say that in this case, the values are closer to 6. But if my sixth value is 57 or 58, in that case, if you will calculate the mean, that is summation xi upon n, that is to sum of all the values in the range divided by number of values, then in that case, what happens is the mean deviates, and mean does not represent your data correctly. So always remember, when the data is symmetric, in those cases, the mean is a better approximation which can be used. Median is a middle value when the data is order, more robust to outliers, especially in the skewed distributions. So, what is the meaning of median? When you have multiple values with you, what you all do is you arrange those values in a
or in an order. This order might be um, ascending, might be descending, doesn't matter, but the central value. May I request not to annotate the screen? So, okay. So when you are going to find out the middle value, there are different ways of calculations again. The way of calculating this, I mean, group data and ungrouped data is different. But when even if you have the outliers, the central value does not get affected because when you order those values and central positional value here. So median is a positional central value, and then the mode. Mode is the most frequently occurring value, which is useful for categorical or discrete data. Okay, so when we consider the categorical data, or we just saw the data types where we had blood group, or we had the class frequency, uh, we had class divisions A, B, and C number of students, and we would like to find out the maximum frequency class or the maximum occurrence of a particular value. We use mode as the medium. Okay. So this is one of the data set in which they have calculated mean, mode, and median. And we can see that mode is none. Why is so? Because all the values are unique, none of the value is repeated. So there is no calculation of mode here. All right. So box plot we'll see little later. Now we will see real life applications. Mean, when it is used, mean is used in calculating the average exam scores of students or average income of employees. For example, if the average salary in a company is $50,000, it represents that the central tendency of all salaries. Okay. Uh, then there is median. Median is used in reporting national, I mean, median example is given, used in reporting national income levels since income data is usually skewed. Okay. A few very rich individuals, then median household income is often a better representation of typical earnings. And an example of mode applied in marketing to determine the most commonly purchased product, size, or color. So this is a better when you are suppose you have a firm and you are selling some of the products, and you would like to check that which of the products are being sold in maximum, and those products you can focus on more. So there, instead of mean and median, mode helps you the best, right? So this is about mean, mode, and median. Is measures of dispersion, and unlike measures of median measures of central tendency gives you the um, overall central values in the different scenarios, whereas the dispersion is it describes the how your data is spreaded. Okay, so let me tell you a bit about measures of dispersion. Okay, so measures of dispersion by showing the consistency, reliability, and variability of data. So there are different measures. Variance is there, standard deviation is there, range, and interquartile range. Now let us understand the meaning of each of it. So it is the average square deviation from mean, highlights overall variability. How much is the overall variability in the data that you have collected? Then this is the square root of variance, standard deviation, which is interpretable in the original units of the data. Difference between the maximum and minimum values in the data set represents the range. Uh, this is easy calculation, but when you have outliers in your data, so if you don't know what do we mean by outliers in the data, usually your data is remains in the range, and some of the values are extremely away from the normal values, I mean other values, then those values are considered to be outliers. Okay, and then interquartile range is a spread of middle 50 percentage of data. Okay, so Q1 and Q3, quartile 1 and quartile 3 data, whatever is there, that spread is called as interquartile range, and it is more robust to the outliers. So here is one of the example given to you where variance is 4.7 and the standard deviation is 2.17. So what is the interpretation of this calculation? It says that on an average, the data points deviate by 2.17 from its mean. So mean value, x bar is the mean of the values. So how much do they deviate from the mean? They deviate by 2.17. This indicates that there is a moderate spread relative to the data set. All right. So this is an example, the histogram of example data set, which illustrates the variability. Uh, Now let us see some real life examples to understand the concept of standard deviation, range, IQR, and variance. Okay. So the standard deviation in finance, it measures the risk of stocks. So when you calculate the standard deviation, higher the standard deviation, that represents that volatility in the returns will be more. Lesser the standard deviation, volatility in the returns will be lesser. So when you want to calculate the risk in a particular stock, we majority of the times focus on the standard deviation. Then we already see the weather report almost every day. It shows us the maximum and minimum daily temperature. So that is the range where we have say minimum 10 degree and maximum 35 degrees. So range of this temperature becomes 25 degrees Celsius. Okay. Then interquartile range. As we said, spread of middle 50%, right? So when this is used, many a times when you want to find out the consistent performers or consistency in consistently uh, appearing values, you can use IQR over here. So this is useful in exam analysis. One of the example where we identify how tightly students' scores cluster around the middle. So central scores, if your student scores are clustering around the central score, then IQR can be used. And many a times universities or colleges use this IQR to find out the consistent performers. Okay, those who come in the range of interquartile range, whose marks lie in the interquartile range, they are the consistent performers of the school or college or university. Um, then the variance applied in manufacturing to assess the quality control. Low variance in the product dimensions means better the consistency. Higher is the variance, uh, poor is the consistency. So let us understand shortly. Low dispersion means values are close to the center, indicating consistency. So any measure of dispersion, when it is low, we say that the values are more closer to the central value and there is a consistency in the data. High dispersion means what? Their values are spreaded out, and this suggests that there is a high variability in the data. In reporting statistics, both central tendency and measures of dispersion must be used together. So you need, when you are working on the data analysis, you need not focus on only one of the part. Whatever is applicable to your data, whatever makes sense for your data, that should be evaluated, and those results should be used in your data analysis. Not necessarily everything will be applicable to your data, but some of these will be applicable to your data. Okay, now the next one. So we will have a short summary comparison table in which you will be able to see it in a concise manner. What is mean? The arithmetic average, which is sensitive to outliers, and it is best suited when you have the symmetric data. So this table gives you an idea that what is the based on your data which you have received after collection of the data, where your data fits. If your data fits in these key features, then use which method or which measure. Okay, so if your data has more outliers, then you should not go for the mean. But if you can see that your data is more or less symmetric, then you can go for the mean as well. Median is a so average salary of employees is one of the real life example. Then median is a middle value, robust to outliers, and this is good for skewed data. That is where there is a data which is not normal, not symmetric. In that case, we prefer to use the middle value or central tendency value as a median. So median household income to represent typical earnings is the example which we have already seen. Mode is the most frequent value applicable to categorical or discrete data. Then the most popular shoe size or clothing size in retail might be one of the example. Range, the difference between maximum and minimum values that are recorded. Quick but affected by the extreme values. So this is the easiest measure, but it is affected by the outliers again. So daily maximum and minimum temperature reporting does come under one of the examples of it. Then the variance, average squared deviation from the mean shows or overall variability, and the quality control in manufacturing to check the consistency is one of the examples. Standard deviation, the square root of variance is called a standard deviation, interpretable in the original units, and this also shows the spread around the mean. And measuring volatility of the stock market returns, we have seen that as an example again. And then the interquartile range, that is spread of middle 50 percentage of data, which is robust to outliers. And assessing consistency of the student exam scores is one of the example which we had discussed. Okay, so these are the measures of central tendencies and measures of dispersion. There is skewness and kurtosis as well. You can even go for those measures which show you the spread of your data horizontally and vertically, the deviation between that. Those measures also can be considered. Those do come under measures of dispersion. Then the graphical representation of data. Some of the easy graphical representations also make your interpretation more meaningful. Because always remember the numeric values or writing text data every time does not give the picture, clear picture immediately. Graphical values or pictures are easy to understand or get. We get connected to the pictorial representation more easily as compared to the text values or numeric values, right? So there are different graphs which we can use for interpreting your data. So the graphs are bar chart, which are rectangular bars representing frequency or magnitude of the data. These are many times suitable for your categorical or discrete data. And so, for example, how do we read it? When you have to read or interpret your chart, what you have to do is you have to compare the heights of the bars. Taller the bar indicates higher frequency as compared to the shorter bars. Okay. So this is one of the examples. So for example, the students were asked for their preferences, and student preferences are recorded in the different categories: sports, music, reading categories, and then travel and gaming. And here we can see the every bar chart height represents the frequency of that particular category. So, or number of students which fall in that category. And we can see that reading categories has the highest number of students because the frequency of that or the height of that particular bar is more. Then there is another way of representation of your data, a circular representation, a circle divided into the sectors showing the proportions of categories. Uh, Use of this is good for displaying relative percentages of the whole. Okay. And the larger is the size, bigger is the representation, right? Larger slices represent bigger shares. Look at the percentage labels to understand the contribution of each category. So this is, for example, one of the pie chart which represents the market share over here. So there are five companies, A, B, C, D, four companies, and there are other companies as well. And we all can see here that their bifurcation is done percentage wise, and higher the slice, I mean, bigger is the slice, higher is the percentage in that particular area or that particular category. Then we move on to histograms. Now, histogram is a bar-like graph for continuous data. First one we have seen, the bar-like bar chart is for categorical data, right? Now this is for continuous type of data. So when your data is continuous, showing frequency distribution, we are supposed to divide the data in continuous intervals, and then the frequencies should be marked, and this type of diagram you get. And these diagrams are called as histograms. And again, how to read the histograms? The width of bars represents the intervals, height represents the frequency, and the overall shape represents the skewness or normal distribution. Okay, so height represents the frequency. So this particular bar has the highest frequency. So in this particular range, there are more number of values which are lying. And overall, when I'm trying to draw a smooth curve from these covering this bar's height, that curve has a particular shape. So if a curve has a bell shape, then we can say the distribution is normal. Otherwise, the data can be skewed. That can also be found using histograms. Then the frequency polygons, a line graph indicating the midpoints of histogram. So if you connect the midpoints of histogram with the zero here, obviously here it is not connected to the base, but it has to be connected to the zeroth base. Okay. So frequency polygons can be drawn by connecting those points, I mean midpoints of every histogram on the top. The peaks indicate the common values when comparing the multiple polygons. So there might be multiple polygons you can draw together, and you can see the overlapping and diverging trends as well. So these are about frequency polygons. Instead of frequency connecting these dots by a straight line, if you connect these dots using a smooth curve, that becomes a frequency curve. But we don't connect that curve to the zero. So that is about the frequency curve. And how to read it? Observe the overall curve shape, symmetry. So this overall curve shape, as I told you, histogram also can represent the distribution type. So if you are able to see your curve is bell-shaped or proper bell-shaped, then it represents normal curve, otherwise skewed towards left or right, that you can view from your uh, histogram curve. That curve is nothing but your frequency curve. Okay. So skewed curves, what do they represent? They represent the bias towards low or the high values. All right. Then there are cumulative frequency curves also, which you can draw and calculate. The graph showing cumulative totals, less than type curve, and there is greater than type also, greater than or equal to type also. So cumulative frequency below a particular value and cumulative frequency above a particular value is used to draw the ogives or cumulative frequency curves. the intersection of those points. Now, how to draw this? I mean, these are not smoothly drawn here, but when you draw it on the paper, you are supposed to draw the curves which are smooth and passing through almost all the points. Those are called as ogives. Their intersection gives you the median on x-axis. So this intersection, if I draw a line on x-axis, somewhere here my median lies. Okay. This curve also helps you to calculate the percentiles and quartiles too. So this is about your ogives, then line graphs. So what does line graph do? It connects the points with the straight line segments. Uh, the line graph is best suited for the time series type of data. So when you have time on x-axis and values on y-axis, we usually prefer to represent the data using line chart. Then how to read it? The slope of the line shows that the rate of increase or decrease, right? The sharp rise or fall means the rapid change has happened. So here you can see there is a rapid change happened in the sales from February to March and then March to April. Whereas flat lines represent the stability. Okay, so these are another measures. Then there is an important measure in your statistics, which is box plot. Okay, so box plots are also called as whisker plots. They display the median, quartiles, and outliers. Okay, so this is basically a box plot. This middle yellow line you can see is called as the median line. It represents the median on the y-axis. If I draw the line, then how to read it? The central line is median. Okay, so this central line is median. The box shows the middle 50 percentage of values. So middle 50 percentage, that is IQR range values, interquartile range values lie in this box. Okay, then whiskers show the variability. Your values are varying from here to here, here to here are the variability. Now you are not able to see any dots there, but if I draw any dots over here, one, two, or rather not there, it should go beyond your whiskers, not within your whiskers. The dots below your whisker are going, those dots or some of the dots that may go above your whiskers, just a second, those dots are called as outliers. Okay, so box plot is also called as 5-point summary plot, and these all things are represented by a single plot in which you get interquartile range, you get median, you get the viscous, I mean variability range, as well as some of the dots which are outside the data, outside this viscous and box plot, those are your outliers. Okay, so those will be above this whisker line and below this another end of whisker line. Then there is one more called scatter plot. So if you have a paired values x and y, and you would like to find out the relationship between the two, then there is the relationship is also calculated in terms of correlation and useful in identifying whether it is for positive, negative, or no correlation. If the points of the slope is upward, I mean point slope upward, then we always say there is a positive correlation between the two parameters x and y. If it is downwards, we say there is a negative correlation between x and y. And if they are randomly scattered, we say there is no correlation. Now here you can see there is an upward trend over here. Height and weight are height and weight data is with you. That data is arranged in a XY format, and every height weight point is plotted, and those points are forming a particular pattern. Now you have to observe this pattern. If this pattern shows you the increasing dots or increasing points, that shows that there is a positive correlation. If the pattern shows that the points are decreasing, negative correlation. If there is no pattern seen, there is no correlation between x and y. That means as x increases, y also increases, x increases, y decreases, or something like that. So that finding out those will be your correlation and
The scatter plot helps you to find out the correlation between the two. It is a raw measure of correlation. Okay. Now there are probability distributions. So what are different probability distributions? Uh, First of all, let us understand the meaning of probability distribution. Probability distribution describe how likely the different outcomes are. Okay. So probability distributions describe how likely the different outcomes are. So when you are experimenting something or you are carrying out some experiment and you are getting some output. So what is the difference between or what is the similarity between the different outcomes is the probability distribution. Okay. Uh, Now, what do they provide? They provide a mathematical model for random phenomena and are the foundation for statistical inference. So, we are going to learn inferential statistics. So, for the inferential statistics, these distributions give us the foundation for that. So, first distribution is the binomial distribution, which applies when the experiment has only two possible outcomes, that is either success or failure. Repeated independently and many times, then the probability of success is p and probability of failure is 1 minus p. So probability of so the p of x equal to k is given by this formula. Now understand the interpretation. I will only go through this data because this particular things will be useful to you, but only after understanding this statistics behind it. So it gives the probability of observing exactly k successes out of n trials. If p is equal to zero point 0.5, the distribution is symmetric. For p is less than zero point 0.5 or greater than zero point 0.5, the distribution is skewed. The mean is expectation of x is equal to np, and the variance is variance of x, which is given by this formula. So real life examples will be number of heads in 10 coin tosses, number of defective bulbs in a batch of 20, or number of patients responding positively to a new drug trial. These can be your some of the examples of binomial distribution. Then this is a binomial distribution figure. Uh, then there is a normal distribution. Okay, the normal distribution is a continuous probability distribution which forms a bell-shaped curve of your data set, symmetric around your mean. So the values are symmetric about around your mean. Values are spreaded symmetrically around mean with the spread controlled by standard deviation sigma. About 60 percentage of values lie within mu plus or minus sigma, 95% within mu plus or minus 2 sigma, and 99.7% within mu plus or minus 3 sigma. This is the empirical rule. The shape of the curve shows the concentration near the mean, with the probabilities tapering off symmetrically. Many natural social processes follow this distribution. So many times you will come across this type of distribution in your data set. So real life examples will be height, weight, and IQ scores in large populations. Then you may have measurements errors in scientific experiments or stock price fluctuations in the finance. Approximately may normal in short run, not necessarily long run. And this is the normal distribution curve usually. Then Poisson distribution. The Poisson distribution models are the number of events occurring in a fixed interval of time or space under the assumptions that events occur independently and at the constant average of average rate lambda. Then this is the formula. Now, what is the interpretation of this? The mean and variance of Poisson distribution are equal to lambda, and it is useful for modeling rare events over the given interval. As lambda increases, the distribution becomes more symmetric, and as the value of lambda increases, the distribution becomes more symmetric. That means it approaches to the normal distribution. Some of the real life examples where it can be applicable is number of phone calls arriving at a call center per hour, number of printing errors per page in a book, number of accidents occurring in a traffic junction, occurring at a traffic junction in a day. So this is where lambda is equal to 3, you are getting this type of structure. Okay. So now we will move on to the inferential statistics. So these are some of the tests which you will be using during your um, data analysis majority of the times. So let us move on to inferential statistics now. Okay. So inferential statistics helps us to draw the conclusions about the population using the sample data. Okay, so you have collected the data set, you have the sample data with you, and based on using that sample data, you are going to draw some conclusions. Um, and there we are going to use the different tests based on our data, and then those tests will give us the different results, and we are supposed to interpret those results and draw conclusions about the data that we have collected. Okay. All right. So they allow researchers to generalize the findings, test hypotheses, and make predictions. Now there is first test, which is t-test. A t-test is used to determine whether the means of two groups are significantly different from each other or not. It accounts for the sample size and variability. So this is how the t is calculated. T value measures how many standard errors are the difference between group means is away from zero. That is the null hypothesis. Then a large modulus t value means the groups are unlikely to be from the same population. P value tells us, the probability value tells us the probability of observing such a result if the null hypothesis were true. And if your p value is lesser than 0.05, the results are considered significantly significant. That is, null hypothesis is to be rejected. Okay, that is, p is less than 0.05. That means there is a strong evidence against your null hypothesis, that is h naught, whatever you have assumed is not true. And then you are supposed to accept the alternative hypothesis. So every null hypothesis has an alternative hypothesis. The t-test is a robust, but for small samples. What are the assumptions? Independence of observations and approximate normality. So there should be approximate normality in your data set, but equal variances for independent sample t-test. So where you will come across this real life examples, testing whether the two teaching methods result in the different average exam scores. So we have applied two different teaching methods. So we one of your teacher is experimenting the different teaching methods, and with one teaching method she had written your scores in one of the column, and using another teaching method whatever scores you have scored are written in the another column. Basically this data is many a times approximately normal, so you can apply this test and to check whether the two methods have significantly different results, or they have significantly, I mean, there is no significant difference between the means of the mark scored, we can use t-test over here. Similarly, when you want to compare the effectiveness of two drugs in clinical trials, the way we compared the two teaching methods, similarly, you can use the um, I mean, if you are there in medical field, two drugs are tried on for a particular treatment, and you would like to check the effectiveness, or you would like to check the average machine output differs within the two shifts in a factory. Okay. Then we move on to correlation. Correlation measures the strength and the direction of linear relationship. So we assume that there is a linear relationship between x and y between the two variables. Then R is calculated, that is, coefficient of correlation is calculated, which varies between -1 and 1. -1 represents the perfect negative correlation, that is, as x increases, y decreases, and in the same magnitude. Whereas +1 is perfect positive correlation. Then there is a range for weak correlations like weak positive, weak negative, moderate positive, moderate negative, strong positive, strong negative, which lies in this range. So, but you must remember that correlation does not imply causation. External factors or co-founders may explain the observed relationship. So, correlation only tells us about the relationship between the two, but causation is not something which is explained by the correlation, or it does not imply, I mean, correlation does not imply causation. Okay. So, some of the real life examples are R studied versus exam scores, amount of exercise versus body weight, and advertising expenditure versus the sales revenue.
Uh, this is a scatter plot. You are able to see that there is a strong positive correlation in whatever uh, curve is drawn over here. I'm not getting into all the details of this because there are few more pages which we have to go through. I think time is running faster. Then regression models. Regression models assume the relationship between the dependent variable and one or more independent variables. Okay, so you may have a dependent variable and one or more predictor variables, right? Like a value of y is predicted by one or more xi's. That is, if this is a case, there are different regressions. There is the very simple regression, which is majority of the times used, is simple linear regression, in which your equation is somewhat like this: beta naught plus y is equal to beta naught plus beta 1 x plus epsilon. Epsilon is a error term. And now see here, what is beta naught? Expected value of y when x is 0. Beta 1 is slope, that is change in y per unit in change in x. Epsilon is a error term. Okay. So a positive slope indicates as x increases, y increases. Sorry, as y correct, as y x increases, y increases, and a negative value of negative slope will obviously mean y will be decreasing as x increases. Now there is another measure called r square. Okay, r square is the coefficient of determination, which shows us how much is the variance between y, how much of the variance in y is explained by x. Okay, so regression is more powerful than correlation because it allows you to predict and hypothesize. The hypothesis testing is also applicable here. So what are some real life examples? Predicting the salary based on number of years of experience, forecasting the sales based on the advertising budget, estimating blood pressure from age and weight. So here you can see there is not only one variable, there are two variables here. So that can also be used. Okay. So this is one of the example which is given over here. Now we will quickly go through the summary data, summary table. T-test, what does T-test do? It compares the means of two groups. Then what does correlation do? It measures the strength um, and the direction of the relationship. Regression predicts the dependent variable from independent variables. What are the outputs of t-test? P-value and p-value. Correlation mein output is R, and regression equation and R square are the outputs which we receive from regression. Then range of values. Range is, there is no fixed range here. Correlation values lie between -1 to 1, and R square is square of correlation value, usually approximately that value only comes. And so it lies between 0 and 1. The interpretation test if groups means are differ significantly. It quantifies the association, but no causality. Then this explains or predicts how y changes with respect to x. And some of the real life examples are written over here. Now, some of the advanced methods are also used. ANOVA will be one of the method which you will be using in your data analysis many a times. Analysis of variance test whether the means of three or more groups are equal. So we have seen two groups के लिए t-test was the three or more groups के लिए generalized t-test, that is one way ANOVA. There is one way ANOVA. Between group variance and within group variance, you get the F value. The F statistics compares the variance explained by group differences to the variance within the groups. A large F value suggests that the least one group mean is different. What are the assumptions again here? Independence of observation, normality within the groups, and homogeneity are the assumptions to use ANOVA. ANOVA tells us that the groups differ, but not which groups and for what. That so for that purpose, we have to use post hoc analysis and post hoc test are there. Uh, then some of the real life examples is comparing average marks of students from the three schools, testing the effect of different fertilizers on crop yield, and so on. So this is the variability, I mean, a box plot for ANOVA type of comparisons. Then chi-square test. The chi-square test evaluates the association between the categorical variables by comparing the observed and expected frequencies. So this is the formula to calculate chi-square. A large chi-square value means the variables are likely associated. What are the assumptions? Sufficiently large sample size and expected frequency in each cell is at least 5. It does not tell us the strength of the association. Okay?
Only whether one exists. That's only it tells us. Relationship between the gender and voting preferences is one of the example. Testing if the preference for product differs across the age groups. Then checking if the diseases occurrences is linked to the lifestyle factors. These all are the examples where you can use chi-square test. If you have similar hypothesis or similar problems in your data set, you can go for chi-square test. So this is contingency table of chi-square test. Logistic regression can also be used. When do we use logistic regression? When your outcome is binary. Binary means what? Your outcome is yes or no type, success or failure type. So you have some questions in your this right questionnaire where you have yes or no type of questions. There you can use this logistic regression also. The relationship between x and the probability of y is equal to 1 is usually S-shaped. Beta 1 is interpreted in terms of odds ratio and the factor which is by which the odds change for 1 unit in case of x. Again, the assumptions are here independent observations, linear relationship between log odds and predictors, and the absence of multicollinearity. Unlike linear regression, predicted values are constrained between 0 and 1. Okay, predicted values will be constrained between 0 and 1. So, what can be the real life examples? Predicting whether a student passes or fails based on the study hours. Because your predicted value will be either 0 or 1, estimating the probability of loan default from applicant's income and credit history, predicting whether the disease is present or not present based on the risk factors. So logistic regression is what is the output which you are going to get from logistic regression? It will be of binary type, either 0 or 1. All right. Let us go through the summary now. Summary for ANOVA, chi-square, and logistic. These compare the means of 3 cluster groups. This tests the association between the categorical variables, and the logistic regression predicts the probability of binary outcome. What all things you are going to get? F value and P value based on which your based on your which your interpretation matters. Chi-square value and P value, coefficients, then odds ratios and predicted probabilities will be the output. What kind of data type is applicable? Continuous outcome and categorical predictors. Categorical outcome and predictors both should be categorical. Then here binary outcome, continuous or categorical predictors are acceptable. What is the interpretation? Significant F means the at least one mean differs. Significant value of chi-square means the variables are associated. Coefficients explain the effect on log odds. Then, what are real life examples? We have already seen the real life examples. Yeah. Now, there is one short case study, which I'll quickly run through, and then we can,
that will be from my side. So we have the data about 10 individuals. Their education is listed over here, and monthly income in thousands is listed. Descriptive statistics, mean, variance, and standard deviation are calculated. Correlation is 0.98. So that means there is a very strong correlation. What is the meaning of very strong correlation? Very strong correlation means higher the education, closely associated with higher income. Okay, this is the scatter plot of education versus income, which is drawn. Then simple linear regression, they have fitted beta 1 value is 1.93, beta 0 is 4.9. So the model which is fit, that is the regression line. What is the regression line? This line, okay, this red line. Equation of this red line is this. What is the interpretation? Each additional year of education increases income by these many dollars. When education is zero, the income would be 4,900. Okay, so this is the interpretation. Again, the same line because correlation had the similar line. Then ANOVA has been calculated. The regression model can be tested using ANOVA decomposition, and then F value is 130.0, which is very large. So model is highly significant. P value is very, very less than 1. About R square is 0.985. So of the variation in income is explained by. So 98.5 percentage of variation in income is here explained by the education. Then residual analysis can also be done. Residuals are small and randomly scattered, no major deviations from linearity and constant variance. So this residual analysis we have not, but you can even get the residual plots using the when you feed in the data set to your one of the softwares which you are using. So the final insights about this particular case study are each extra year of education substantially increases the earning potential. The strong correlation that shows education is a key predictor of income. Regression model is very highly reliable because 98 percentage of variance is explained, and policy implementation is investing in education can significantly raise the income levels. So why I have given you this last case study is your problem can be of similar type. Once you collect your data, you may have to fit your data in such a manner that which all tests are applicable to your data, what all graphs can be applicable to your data, uh, uh, what insights you are gaining from your data. To represent that, you will be using the correct measures, and then you are going to present your report. So this is it. That's it from my side. If you have any questions, you can ask.
Thank you so much, Dr. Pratiksha,
Yeah.
madam. And
Yes.
students, if you have any question, please ask, or you can write in the chat box.
Yeah, you can write it in the chat box. That's also okay.
You can unmute, and students, you can unmute yourself and ask the question. I think, madam, they have not started, they have not yet reached to this stage of data analysis. So when they will start doing it, then only they will come across the questions, and definitely we will get back to you for their questions. Thank you so much for joining us. Now I would request Professor Michelle to propose vote of thanks to the madam. Professor Michelle?
Yes, ma'am.
Yeah.
On behalf of the entire team, I would like to express our sincere gratitude to Dr. Pratiksha for delivering an engaging and insightful session on quantitative research methods. your ability to convey those examples and relate to real life situations was immensely valuable. And I'm sure the students would also be able to relate it once they apply it on their research projects as well. I would also like to extend my appreciation to all the participants for their patience and their participation. And additionally, I would like to acknowledge our organizers and support team for their efforts in ensuring smooth execution of this meeting. Thank you so much, ma'am, for your insightful session, Dr. Pratiksha.
Thank you so much. Thank you, ma'am.
Thank you, ma'am. Thank you so much.
Thank you so much.
Students, feedback form link is pasted on the chat box. Kindly fill the feedback form and then leave. Students, please fill feedback form and then leave the meeting. You can leave meeting after filling feedback form.